Thanks everyone for joining us. We're going to talk about a feature of Salesforce that Salesforce really doesn't talk about at all, called Einstein. Thank you for getting the joke. So we'll do introductions in a second. But before we do, we've kind of raise a hand just to understand the crowd. How many of you are Salesforce administrators? Awesome. How many of you are also Salesforce developers? Awesome. And how many of you have any sort of experience with data science, machine learning, AI, whatever you want to call it? OK, that's great. So let's begin. We're going to talk about really the building blocks behind Salesforce Einstein and kind of give you visibility to what goes on under the hood of creating artificial intelligence at a massive scale with a lot of customization. Really, we will going to walk you through the challenges that we faced as a team building it. But before, I guess there is a slide that our marketing team really wanted to showcase their PowerPoint capabilities. So let's all spend a second to admire how beautiful the slide is and move on. So I'm Vitaly Gorin. I'm Vice President of Data Science and Engineering for Einstein. I lead the technical development. Sarah, who's here with me, she's a senior manager of data science. It's actually been a long kind of dream of mine to be on the same stage with Sarah and actually give this presentation. So I'm very excited, as you can see, and it's going to be great. You guys all should be excited as well. And we're now going to show the most exciting slide that there is. If we don't have this slide, it's not a Salesforce presentation, our forward-looking statement. So please don't make buying decisions based on what you're going to see, and you've probably seen it enough. So, you know, I hope you'll forgive me for skipping the slides before you can read all the text in it. OK, so AI. It's here, and it's here to stay. There were times, you know, in the 90s that kind of AI was going through what's called the AI winter, where there was a lot of promise, but it really did not work as promised. And you know, a lot of these techniques were created in the 60s, and it took really a long time to get them to work. But today, they're pretty much everywhere. We have natural language understanding. We have all these personal assistance tools like Siri, Cortana, Alexa, etc. Pretty much everything that you shop today online is backed by some form of artificial intelligence. There are, you know, visual recognition, face recognition, object detection, etc., etc., etc. And it's only, you know, growing more and more, where at some point, we'll stop referring to things as a, you know, smart watch or a smart car or a smartphone. You know, there will be just, you know, watches and phones, and everything else will be simply stupid. So the typical AI app focuses really on one business process. If you think about the consumer internet, where a lot of the AI started from, they have really kind of one process that is dictated by that platform choice. If you take, for example, Facebook, right? Facebook really doesn't come to you as their user and ask you, hey, tell me about how you lead your life. You know, what is your social experience that we're now going to tailor our platform to your social needs, right? No, they come and say, hey, this is a very prescriptive way of saying, you know, this is what a social platform is. This is how you can interact. This is how you can like a picture, you can comment, you can poke, you can do whatever. But it's hardly customizable. Like, everyone uses Facebook. It doesn't matter if you're a farmer in Indonesia or, you know, a tech employee at Silicon Valley. You kind of use the platform in the same way. You know, you see similar journeys, find a feature set, and kind of the metrics are fairly well defined and understood. But this is really not the case for a lot of enterprise products. And that is why, you know, a lot of people say when we see that the enterprise is really lagging behind the consumer space when it comes to AI. And there is, you know, reasons, and this is really what we're going to discuss today, why is doing AI in the enterprise is so much harder than the equivalent kind of consumer space. And this is kind of the, the standard process. It has a very catchy name, CRISP-DM, which stands for what you see here, but you can understand the blocks. Basically, there's the business understanding, the data prep, modeling, evaluations, so on and so forth, and rinse and repeat. This is kind of what a data scientist does as her daily job. But what happens if companies usually don't have just one intelligent app, right? There is we have a lot of processes in our companies, and we need really to add intelligence to every one of these processes. So, hey, after having data science number 1, we hire data scientist number 2, and data scientist number 2 works on the second process that we want to optimize and infuse intelligence in. And, you can now get story, it's number 3, and so on and so forth. But basically, there's kind of the point we're trying to make here is usually there is, the process is, it's a very manual process. There is usually a person or a team of people that really go and take one process and try to optimize it. And that process, as you can quickly see, is really, doesn't scale. And for the majority of businesses, data science is really out of reach. There are, again, whatever you want to call it, but there's, there are maybe thousands, maybe tens of thousands of people that have the right skill set. And there are way, way, way more companies that require the skill set. And some of the problems are around just ETL, like moving data from one place to another. This is a really hard process. Large companies have data warehouses, databases, and kind of in order to do data science, usually it means you need to get all of your data and move it to one place, which requires complicated ETL tools like Kafka, and transactional databases, data warehouses, NoSQL database, and so on and so forth. It's really now becoming this whole practice of just moving data from one location to another. The second thing is there's really a math understanding. All of these statistical algorithms, they're not sorting an array. They have dozens of knobs and tweaks, and they have a lot of math understanding behind them, and they're all non-deterministic. There are some, not necessarily random elements in them, but they have some statistical elements that sometimes you can run the same algorithm on the same data, but just kind of change the order of the rows and get two completely different results. That's just the nature, and one has to deeply understand some of the math principles of understanding how to use these algorithms properly. And the third thing is really the DevOps, is because usually there is a correlation between the quality and the accuracy of these algorithms with the amount of data a company has. And with amount of data, there is a large amount of problems. And some companies have so much data, and then we go to the space of large data processing frameworks like Hadoop or Spark or whatever the flavor of the day, and just to know how to tweak and make sure that all of these applications have the right load balancing, and they're scale up and scale down, and all that DevOps is really again an expertise that requires very special people that not necessarily every company has an access to, and this is really kind of the three, I would say, main problems that we're trying to solve. The way we think about Salesforce Einstein internally is really kind of the moniker for us is no ETL, no PhD, and no DevOps, and this is kind of will take you through a journey of how we go about actually achieving that. This is how this process really looks at Salesforce scale. Is you can see example of 3 customers here, and you can see that every one of these circles is an app. And we have hundreds of thousands of customers, and there's really not enough data scientists in the world to produce all these circles I just showed you. Even if we hire all of them, it will not be enough. So we had to really do something different. We had to rethink about how one approaches it. And again, just to understand, previously I was working at LinkedIn, and looking at the number of circles for all, of all the processes can be basically measured in dozens, right? Here for just one app, and because there are so different processes, and everyone has their own, unique data, and the business needs are different, it's really about creating hundreds of thousands, if not millions, of models in order to serve these needs. And these are just some of the examples of prepackaged apps that today come with Salesforce Einstein. And I can promise you, not every one of these apps times every one of Salesforce customers has a data science team working on it. So Sarah will tell you a little bit more about how it works with Salesforce Einstein.
Thanks, Vitaly. So I'm not as funny as Vitaly.
That's a high bar, Sarah.
But I'll try my best to be interesting, if not entertaining. So I want to cover how Salesforce Einstein accomplishes this goal at a high level, and then afterwards we'll take you through a little bit more of the details of what we learned along the way. I know there were hands that went up, but we'll go through some of the basics and then build up from there. So first, some 101 for AI, and for those of you that are familiar with this process that was discussed earlier and all of the things here that we're defining, we'll get to the next part quickly, but I want to cover this from the perspective of lead scoring, which is a product that we have GA right now. So if we're going to go through the details of wanting to predict which leads are likely to convert in a Salesforce object, how would we go through actually building up a model here and then discussing what is required to make that happen? So some definitions for words that you'll be hearing for the rest of the talk. We'll start off with response. So that's the thing that you want to predict. And here we'll be talking about a lead likely to convert. So if you have a list of leads that are in, which one is likely to convert? And that's the response that you're trying to predict. What we would want is for that to be fed back to our users so that they know what to go after. Features, which you may hear in other contexts, in the context of AI, mean the attributes that you're measuring or that you've measured and converted into something else that allow you to predict an outcome. And so specifically here, it might be completeness of a lead, it might be the company or an email domain, some of the features that you might extract from what's available about that particular lead. So the model, Vitaly talked a little bit about these statistical methods. It's how you actually relate all of those features to that outcome. And there are any number of algorithms out there that make it possible for you to do this. There's some listed here. You can go to a lot of different, there are like open source libraries that can list them all out for you. So logistic regression, naive Bayes, random forest are some listed here for classification. Lastly, scores. So anytime that we have a model and we have new data that comes in, our goal is to predict what the outcome will be. And we refer to those as scores. And that's what you will use going forward to serve up to your customers so they can prioritize their work on which leads to go after. Now, if you've used Python before, this might look familiar to you. For everybody else in the room, it's a common way for data scientists to get oriented with data sets. Whether or not it's easy to run in production is a different story. But often what you can do is start off with a data set, and here we'll go through an example. There are libraries out there. Scikit-learn is a common one. We'll be using SVM, which is support vector machines. It's one of the methods out there for being able to do prediction. So we might be importing some other libraries, and our goal is to use that particular algorithm to be able to predict here a lead scoring result. So we'll load up some lead data, then we'll actually figure out how to process that data. So we'll pretend it's coming in a CSV. What we're then going to do is decide X are going to be our features, Y is going to be that predictor that we had before, and we're going to build a model. So what you see on the next line there, just before that big block, is how we actually call that function to fit on our what we're going to call training data. So the line above that, we're basically taking everything except those first two examples. We're going to hold those out later to see what the result is on a test set. Now, lastly, you can see how well you perform by predicting on the ones that you held out. So a few things that Vitaly was talking about earlier that we're kind of skipping here. So the part around like figuring out the business process and feature transformation and understanding what's in there. We'll just imagine, let's say that's all magically solved for us. But some of the issues now, if we're just going from one customer to the next. So if we wanted to use this at Salesforce for all of our customers, there are a few problems. So one is that we don't know necessarily if what we're building is always going to be exactly the same. So the data sets might vary. Let's assume that we can solve that problem. It's possible that the data that we're working with might not be best fit by one algorithm or another. And you can see all of the stuff that's printed afterwards. These are all default parameters. They might be needing to be explored a little bit. So, what type of kernel do we want to use to transform all of our features? There are any variety, like the tolerance. So what do we want to set, and how do we explore it, and how does that vary by different customer, since we're building models for every individual customer? And lastly, we want to evaluate how we did. So you can see that there are any number of problems, particularly when we start applying it to the concept of all of our customers that are out there that could potentially start using this application. So the way we solve that here, and we'll talk a little bit more about the details, but at a high level is that we've built a set of services that make it possible for us to do this going forward. And specifically what we do is anytime a customer comes in, we try out a whole bunch of models, transform a bunch of their data into features, and they're customized for what is available in their objects in Salesforce. So all their custom fields, we can use those as well. And we test out a bunch of the different models. We kind of have a race there and figure out what the best one is. And that's the one that will be used for that particular customer. So it's on their individual set of features, and it's also the best one of the set of parameters that we can possibly explore, and the set of different model forms. So logistic regression, random forest, whatever it may be. When our next customer comes in and tries to do the same thing, so they sign up for it, we do the same thing. We build all of these models for them, transform all of their data, and then we get a bunch of different models out and pick the best one. So the one that's running in production is best for them, as opposed to what the previous tenant may have wanted. So what we had to do was build up a whole bunch of services along the way to make this possible. We also have a machine learning library that runs on top of Spark that makes it a lot easier for our data scientists to start up and be able to make this. So we're not going to go into too much detail there. There are a few talks, Optimus Prime, out there to cover that. But instead, we want to talk about what it actually means to make it possible to build AI here at Salesforce. So everything that I talked about there and what Vitaly mentioned earlier, that's really important for us is to actually have this central AI platform that makes that all possible for us to allow our customers to sign up and to use their own data, build models, and solve that DevOps issue, so the no DevOps. Then also the automation. So if we want to scale up hundreds of thousands of customers, we can't have somebody coming in necessarily and checking on every individual thing. So instead, we have to automate that process of running things through and teach the computers how to actually learn from the data, transform the data appropriately, and make it possible to go forward. So obviously, getting there was a longer journey. We can talk through how we got there. So Vitaly, I thought we could talk about the lessons that we learned along the way while building these apps.
OK, awesome. So we have 15 minutes to go through 10 kind of lessons learned. The reason why we decided to focus more on the lessons learned as opposed to like whatever the technical solution is because I think what we realize is every enterprise company that will try to solve a similar problem will face kind of these issues. So here is kind of fast forward for you in case you're just getting started. So the first problem, Sarah, like what we discovered, we have really different sizes of customers, right? We have some customers that have, I don't know, like tens of leads per day, and some that have millions of them. So, what did we do about it?
Yes, you're definitely right. We have to be able to deal with any size volume of data that comes in. So everything we do, we run on top of Spark, so that scales. We're able to handle massive amounts of data. And we've also figured out how to tune that so that given the data that comes in, we can be aware of it and make sure that we have the right settings to run efficiently for that tenant on Spark. So that's definitely one thing that we see in terms of variations, the size of the data, but not every tenant looks the same, and actually that results in things where we might be wanting to predict like the color of pencils in here, but in other instances we might be finding a needle in a haystack. So that's a really different problem, Vitaly. How do you work with that?
So just to reformulate the problem is some of the customers, whatever the process is, it depends on the process. Let's say, some of the companies have leads that, 50% of their leads become, let's say, opportunities. In some cases, let's say only 0.1% of the leads turn into an opportunity. That's just how different businesses are. And really, a 0.1%, 1 in 1,000, creates an interesting problem in machine learning, because then if you have a model that always say that lead will never become an opportunity, that model will be 99.9% accurate, which is great, right? But it's useless. So it's really about, in some of the cases, it's really not so much about classification. It's more about almost anomaly detection, and it requires a different set of algorithms. And this is something that we kind of train Einstein to do based on the data distribution to understand what really the algorithms that are right for that problem, even though it's supposedly the same exact process in the same exact problem. Another problem that we just found, and it's kind of funny to look at it in hindsight, because it's so obvious, but customers have different languages. So what do we do there, Sarah?
Well, that's actually a really important problem. I speak multiple languages. I understand that they're really different. So every time you're looking at language and you're wanting to explore some text fields, you want to use something like natural language processing, which we do, to work with those text fields. What we need to do is actually process them differently. So even the way words are spaced may vary. It might not be by space or by dot, the way things are interpreted. Beyond that, it's also the words themselves. So we want to be able to recognize how to stem a word. So something like run, running, ran, we would want to refer to one item. And so we need to use different languages. So in OP, in our Optimus Prime, what we do is detect the language that we're working with, and we apply the appropriate set of transformations for each individual language to make it possible for us to actually do something that's appropriate for that tenant in the language that they use.
That's really cool.
So you mentioned earlier about the size of the data sets that we're working with, and it just seems like sometimes if you just have tens of leads, maybe you don't actually have something to build a good model off of or problem to go after. What then, Vitaly?
So Phil, our vice president of go-to-marketing, probably will hate me for that. But guys, if you have 10 leads a day, you don't need a lead scoring solution. So kind of, take my word for it, call everyone. Just skip the solution entirely, call every single lead, and just, like AI is not, a one glove kind of fits all. Not every problem really needs AI to help you solve that problem. So in that case, we're really just, we actually evaluate our customers when they are interested in one of the Einstein products, and based on the size and shape of their data, we actually produce a recommendation on whether, kind of how useful this product will be for you. And this is another problem that we kind of mentioned, and that's really, every single customer has a different process. In lead scoring, for example, some of you might convert your leads to opportunities. In some cases, you might convert them to accounts, and in some cases, you might convert them to contacts. So what do we do about that, Sarah?
So that is something that we have to allow our customers to define. They have a process, and we want to make sure that what we're predicting is the thing that they care about, rather than just something that we think is interesting or appropriate. So what we do is allow that to be a customized answer, so you get to define what your success looks like, and actually build models. Again, the same way we do with features, we can also let you decide what your label is and predict that instead.
Oh, sorry.
So speaking of being able to define your success, there's also a lot of other stuff that we keep talking about, and you can just customize it until you end up with whatever it is that you desire. So how do we handle that kind of stuff?
So customization is even, again, when we talk about leads, so while Salesforce comes with a standard lead object, there is a lot of custom fields that are added. And honestly, what we found that a lot of the signal is actually in those custom fields. It's not in the standard fields that come with the Salesforce schema. And it's actually kind of very interesting on how to approach when every single customer have different fields. And like I said, in none of these steps, in none of the Einstein product, there is a human in the loop. This is, again, something very important to always to remember. And there we do kind of certain tricks based more on the metadata of the rich metadata that Salesforce has. Like, for example, if you guys have a phone number, we don't really care what that phone number is. We know that the predictive part of a phone number is usually the area code and not so much what comes after the area code. And you can think about the zip code is actually the first digits are more predictive than the last digits in a zip code, and so on and so forth. So for every single metadata, type of field in Salesforce, we have our own automated kind of feature extraction that really helps us to deal without looking at that data kind of in particular. And then we go to, this one of my kind of favorite cartoons, which is AI needs trust. It's, especially like I said in the beginning of my talk, AI has been promising thing for 50 years now. And really, until recently, it never delivered, and even more so in the enterprise space. So naturally, when we come to you or our customers saying, hey guys, we created, it's the best thing ever, better than sliced bread. So, obviously I'm not a sales guy. What do we do about it, Sarah? How do we gain our customers' trust that our products really work?
Yeah, well, I mean, an Einstein character definitely makes it clear that we know what we're doing, but we definitely want to deliver a little more. So what we do for lead scoring is that we actually provide information. We work really close with the UX team to make sure that we explain to our customers why it is that we believe that this lead is actually going to convert. And so what we do is we build these models and make sure that of all those features, remember those predictors that we have, we explain which ones are influencing that we believe it will convert, and what in your data is actually signaling that we can see the difference. So I think that goes a long way, besides just having big white hair. Well, so we definitely have to continue learning along that process, so we keep delivering things back to our customer, but it's not like the first time we get data, things might change, we might grow and learn more. So is it something that we feel we deliver, we ship, and then we're good to go? How do we deal with the fact that data keeps coming in? We have more and more to learn.
So this is really kind of, it's kind of obvious, but this is something that we, at least from my career, I found that a lot of people skip is the learning part of machine learning. They kind of learn once and then, deploy and forget about it. But this is really one of the areas where we devoted a lot of our thinking, is how to create that feedback loop that we can create actionable, actionable kind of insights, and then when kind of the users take actions based on these recommendations, we actually get the result of that action and feed it in. And there is like a myriad of interesting problems that one has to address, like for example, a presentation bias, where some of the actions, like in the search or recommendation engine, you click on a search result just because, well, it was the first search result. So it's kind of obvious. It doesn't mean that whether that search result was any good or not. And these are really, there is a lot of statistics that needs to go on proper kind of experimentation and kind of proper measuring of ROI in order to really know whether these products are delivering the value that we all wanted to deliver. And kind of goes with that, there is a notion, especially when you do automated machine learning, there's what's called the leakage problem. So for example, if I build kind of a prediction engine to predict whether a customer will buy something, and I have my data where all the information is available without timestamps, which is in many cases Salesforce being kind of a CRUD database. It has, here is the example of you can get the thank you for ordering email, and then a naive model will learn that, hey, the existence of a thank you email is a great predictor for purchasing, where we all know that the causality is obviously reversed. So how do we deal with that, Sarah?
So that actually is a fun problem. The way we work with that is within Optimus Prime, our machine learning library that we have, we test to make sure that we don't have this leakage. So we can actually go through and see if something looks too good to be true, like every time someone's going to buy something, they get this email. Well, then it probably is too good to be true. So what we can do is systematically check whether or not with the features we have, they are leaky, they are possibly leaky, and just remove them from our model and actually ensure that way that going forward when we get fresh data, we're not predicting something that will never be present, like an email, before you make your purchasing decision. Okay, well, we talked about all these things that we learned along the way, and there's sort of maturity on the data science side, I guess growth maturity or evolution. There's also on the customer side a lot that's happening. So how do we handle the fact that we just have a lot of variety in terms of where the skill sets are at right now?
So this is honestly probably one of our biggest problem. We're really trying to, with Einstein, create a platform that will adhere to any level of expertise. So our internal data scientists people like Sarah with a PhD from Stanford use it and get value, and people that without any technical background and definitely not a machine learning background. And really that forced us to think hard about what this experience should be like. And this is where we actually went to the inspiration behind the entire project. And this is, Mr. Einstein himself that says, make everything as simple as possible, but not simpler. But the simplicity is really the key, there is a lot of automation that goes behind the scenes on Einstein. So actually the thing that you see in front of you, it looks like, hey, it's simple. Suddenly I have this magical number that predicts. And hopefully from this talk today, you just understood how many of the things we had to solve behind the scenes in order to make that experience look as seamless and as integrated into the platform as actually kind of these products are. So now we are kind of done with our 10 lessons, and really the key takeaways I want you all to go out with is first, enterprise AI is really, really hard. I started my career in the government sector, then I moved to enterprise, then the consumer, and now I'm back. And really, probably the enterprise space is one of the hardest because it's really so customizable and so tailored to the customers. The second key is automation is really the key to scale that. It's like pretty much everything you've seen, every single problem. Once we identify the problem, we solve it in an automated way, and that automation is not just a script that runs a for loop. A lot of it is like, for example, the leakage problem or the language detection have really sophisticated statistical algorithms that contribute to that automation. And in case you guys haven't figured out that from the entire talk, Einstein is awesome. So without further ado, please check out the Einstein Discovery Center. Mr. Julian here, our wonderful product marketing guru, will be giving Einstein demos there and kind of discuss more about what's going on. Take our Einstein trailheads on Trailhead. And if we have I think we have a little bit more time. If anyone has any questions, we'll be happy to answer them. Yes, sir.
In the early slides, we saw if there's a model that's fit for one customer which is not fit. Does that also get reevaluated if the sales strategy changes down the road, or is it once it's identified there?
So I'll repeat the question. The question was whether the kind of per tenant models get reevaluated based on some business process changes. So we have multiple strategies around the decision on when and how to reevaluate the model. Some of them are just time-based. Some of them are more metric-based. So it's not that someone signals us, hey, we changed our business process. It's more that we look for, hey, the current model is now suffering from some performance degradation that sometimes, usually, it is a result of a process change, and then kind of we kind of issue a command to train a new model. Yes, sir.
Kind of follow on to that question. What I have is all this intelligence is getting built, and you said there is no human intervention. So would you translate that Einstein's intelligent in human terms to me? Like if I'm a customer, you're creating a model for me, and then how would you, is there any collaboration amongst models, is one question, and then whatever knowledge Einstein is building internally, how do I know, is there a reverse process for me to know how Einstein is building up this knowledge? Because it's kind of follow on these questions to some extent, because there are sometimes your processes will change. So as a human, I would know my process has changed and my model has to change. But you are inheriting something, maybe an anomaly or something in the model. So there are two things I see happening. There has to be a continuous exchange between the human and Einstein.
So I guess for starters, we do have that UX focus where we make sure that we communicate back the basis of our understanding. It isn't an explicit feedback loop the way you're describing. So if there is a change in business process, Vitaly mentioned we continue to learn, we build models frequently. And so if there is a change that can then be manifested in the way our model is built, it would come out that way. And we do use techniques that allow you to automatically segment. So something like a random forest can actually detect maybe if there are differences in some processes. And over time, we would then be able to predict better what your change was. And we would have subparts of the model basically that present that back.
Another indication is whenever we produce, let's say, we never produce just the scores or just the business outcomes. We actually produce, we try as much to expose information from the model itself. We really are a huge believer in white boxes and not black boxes. So you will see suddenly, like for example, what are the top key drivers in my data that drove those decisions, and you will see suddenly there is a shift. The top predictors that you had yesterday are not the same ones today, and that is more of, again, like Sarah said, it's not that explicit, but that will basically what kind of contributes to the trust. You see, oh, that's right. It's actually you guys are surfacing the new learnings that you made that are actually now representing the change in the process that I just had. Yes, sir. Again, the question was whether there is in ETA, like you mean latency requirements around taking actions in medical. Well, so the answer is we still try to focus, and John Ball, who is the general manager of Einstein, really likes to say, Einstein is AI for CRM. That's really what we focus on, and this is so. Basically, today we're just not trying to go the spaces because we have so much to solve in the space we currently operate. So that's really maybe one day, but we're not there yet.
Are you excluding it as an opportunity, or is it just that because there's so much in the medical imaging, there is definitely CRM is amazing, but there's a big
So I'll answer this way. I'm the tech guy. Like I'm the one that writes the code. You guys, you need to talk. You need to talk to the people who wear nice suits. Yes, there was a question here.
Yeah. So are you going to open APIs for creating and training all custom models, let's say Apex or some?
So the question was that whether we will be opening APIs to create your own custom models. So the answer is yes, and I think we just announced some of the Einstein APIs around vision, sentiment, and what am I forgetting? Intent, yes, thank you. And we'll continuously expand the scope of all the APIs. And again, part of our vision, these APIs are at the beginning at fairly high level. It's like saying, hey, we want to do our best job on solving a very specific problem and really focus on kind of ease of use. And with time, we probably will make them more and more kind of general purpose. Yeah. There was a question here somewhere? Yes.
This may be more of a demo question, but is there a capability of running analytics and reports based on the general lead scoring? Because the management is not interested in each lead, but overall how they can improve the product.
So Phil, please keep me honest here, but I believe that Salesforce Einstein ships with Wave analytics licenses. So that capability is kind of comes out of the box with when you buy Salesforce Einstein, you get Wave analytics as well with it for exactly these reasons. There's people here, they can answer the licensing questions. Yes, sir.
Is there a danger that you missed out on opportunities as the system gets smarter and now we're only focusing on those with the high lead scores, that it narrows down, sort of a Google effect, right? You search these things and now it only gives you those things. Is there a way that we expand and make sure that we're still looking at everything?
So there are multiple techniques to address exactly the issue, but the kind of the high level of the general term is explore, exploit. So usually we always leave some room for kind of exploration, which are, let's call it, without going too much into the technical details, the results are slightly more randomized, and these are actually the things that we learn more as opposed to something that we kind of hard-coded, told you this is the absolute best thing. they play a lesser role in our feedback loop than the ones that have more random elements in them. And it's really an art because, especially in ranking problem like search, we cannot really just give you a random result or a placebo. So there is some dithering there, and like it's really a fascinating subject. But the answer is definitely there is some of the kind of recommendation are more what we call exploratory recommendation, and some of them are more exploit the actual kind of basically to provide the best outcomes. That's it? Yes.
So can models currently accept one input but return multiple outputs? So something we're doing right now with a different vendor is triaging our cases. So we'll take, for like our email to case, we'll take the email body and then return predictions for category, subcategory, and like recipient, essentially. Is that feasibility right now?
So the question was whether models can return multiple results, and it's not only multiple results, it's also results that are somehow have some interaction between them. The answer is it's complex because a lot of what we talked about are packaged apps that are more around. So on the back end, we definitely have this capability, and we definitely use it on some of the packages. Can we mention? So for example, exactly case classification, which is a soon-to-be GA product for Service Cloud, does exactly that. Like it will be a package app that exactly gives you what you just described. So the capabilities are there, but there is also a lot of work that sometimes we intentionally do not expose these capabilities because of the package app nature. Because again, like I said, in Einstein we try to optimize for usability first and customizability later. But with case classification, that will definitely be the case. Okay, well, thanks everyone. Thanks for joining us today.